All right, welcome to College Algebra. We are starting with section 1.2, and it's really going to be a review of a lot of stuff from algebra, specifically lines in a plane. So equation reviews, all right? So you need to be able to identify your equations of lines. So remember that if you see something like this, x equals a being any number, that means it is a vertical line. And a is that x value where it crosses that x-axis. Okay, so x equals a, if it starts with an x, it means it's a vertical line. The way I remember this is that it crosses the x-axis, so it is then vertical. Horizontal lines, however, start with y equals something, and wherever that line crosses the y-axis, that is the b value. Okay, so y equals b, whatever b is, it's a constant. Now the two most common equations that you're used to are the slope-intercept form of the equation, where it's y equals mx plus b, m being the slope, b is the y-intercept, hopefully you remember that. The other form of the equation is y minus y1 equals m times x minus x1, where x1 and y1 are from a given point on the line. And then another formula that should look familiar to you is the good old slope formula. You may have learned it as the change in y over the change in x, and that's fine. If you need it drawn out for you, it's y2 minus y1 over x2 minus x1. So if I do an example for you, if I have 2 points, this is x1, y1, x2, y2. So when I calculate the slope, I start with the second y, and I go 0 minus a negative 10 over second x is negative 4 minus the first x is 1. So subtracting a negative makes it positive 10, and negative 3 minus 1 is negative 5. I'm sorry, negative 4 minus 1 is negative 5. And then that would reduce to negative 2, all right? So hopefully that gives you an idea. Can your slope be a fraction? Of course, it can be a fraction. So now it says to find the equation of the line given the following. So you need to know slope, and you need to know y-intercept to make this happen. So if you're thinking along this line, we need to know the slope and we need to know the y-intercept. Well, in example 2 here, they gave us the slope. And then to find the y-intercept, I always recommend using the point slope formula, which looks like this: y minus y1 equals m times x minus x1. All right, m they already gave us, so I'm just going to plug that in. X minus x1 is the x value that was given. Y minus y1, which is the y value they gave me. But see, the formula says negative, so subtracting a negative makes it positive. Now, over here I got a fraction, and I know most people don't like fractions, so the trick to getting rid of the fraction, taking that denominator and swinging it over here to the left and making it look like this. And then we just do some algebra. We distribute out and combine like terms and solve it so y is by itself. So let's distribute first. We have 2y plus 6 equals x minus 2. I'm going to combine like terms, getting all my constants on the right side. So 2y equals x minus 8. And then I would divide through by 2 every term. So then y would equal 1/2 x. Negative 8 divided by 2 gives me negative 4. And that is my equation of the line. So my goal is to get it slope-intercept form, but in this case we use the point slope form. So start there if you need to. Example 3. 6, negative 1. That's a point on the line. And m is undefined. So you've got to remember your slopes. If m is undefined, that means that this is a vertical line. Undefined means a vertical line. If the m is 0, that means it's a horizontal line. Okay, but if it's a vertical line, m is undefined. And if you recall in the last video, we said vertical lines always look like this: x equals a, right? So in order to write this formula, all we really need to know is what is a. And the way we're going to know that is x equals a. So if you visualize what's happening, it's crossing through the x-axis. Well, what's the x value of my point? It's 6. So that is my whole equation. Because the slope is undefined, it's a vertical line and it crosses the x-axis, so I only need the x-coordinate. That's it. 4 and 5. Determine the slope and the y-intercept if possible. All right, so in order to do this, we're going to have to do some rearranging. We want to get it into this format so we can quickly look for slope and y-intercept. So we need to solve it for y. So more than one way to do this. If I rearrange and I'm trying to solve for y, the first thing I might do is add 9 to both sides. So I have 4x minus 3y equals 9. I'm going to subtract 4x from both sides. So now I have negative 3y equals negative 4x plus 9. I want to get y completely by itself, so divide by negative 3. So y is equal to negative divided by negative makes it positive 4/3 x. 9 divided by negative 3 makes it negative 3. So there's my line. So the slope of this line is 4/3, and the y-intercept of this line is negative. All right, example 5. X equals negative 6. So visualize. That means it's a vertical line doing this right here. Okay, so remember your slopes. If it's vertical, that means the slope is undefined. And the y-intercept, note if it's vertical, it's parallel to the y-axis. It doesn't cross it. So there is no y-intercept. All right? It's that simple. Now, parallel versus perpendicular lines. Hopefully you remember this from algebra 2 possibly, but you need to know this stuff, all right? So here's something you need to write down. Parallel lines means that the slopes of the two lines are exactly the same, and they look like railroad tracks. Okay, and that's the symbol for parallel lines. It's just two little lines, all right? They look like railroad tracks. They never cross. Perpendicular lines are two lines that cross at a 90-degree angle. And the symbol for perpendicular looks like this, if you don't remember. Now, how do you recognize that? Well, you look at the slope of the two lines, and those slopes are opposite reciprocals. For instance, if the slope of line 1 was a 4, then the opposite reciprocal would look like this. You take the reciprocal of 4, which is 1/4, and if this is positive 4, then this would be a negative 1/4. So opposite in sign and reciprocal in value. So number 6 says determine whether the lines L1 and L2 are parallel, perpendicular, or neither. So we've got to identify what are the slopes. So we're going to have to calculate slope here. So we're going to do slope of the line 1. So I do 0 minus 6 under y2 minus y1 over x2 minus x1. Negative 6 minus 3. That gives me negative 6 over negative 9. And that makes a positive value, and I simplify that, and it becomes 2/3. All right, so there's slope 1. Now we're going to do the same thing over here, y2 minus y1 over x2 minus x1, and see what the slope of line 2 is. So y2 is 7/3 minus negative 1, so it would be plus 1, divided by 5 minus 0. Well, okay, so when you add fractions, recall that you have to add common denominators. So this would be 7/3 plus 3/3, which gives me 10/3. All of that over 5 minus 0, which is 5, or 5 over 1. Now when you divide fractions, if you recall, you keep the first, change to multiplication, and flip it over. And then when you do that, you get 10 over 15, which reduces to 2 over 3. So looking at that, my slopes are identical, so these lines are parallel. All right, last example. It is tedious, but you can do this. Now, it says write the equation in slope-intercept form of the lines given through the given point. All right, and so here's the point, here's the line, and example 7 says to make a line that's parallel, and number 8, that should be an 8 right there, that. It is perpendicular to the given line. So before we can dive into this, we need to rearrange this puppy. to figure out what is the slope of the given line. We need to solve it for y. So I'm going to subtract 4x. I have negative 2y equals negative 4x plus 3. Divide by negative 2. So that means I have the line y equals negative 4 divided by negative 2 gives me positive 2x. Positive over a negative gives me negative 3 halves for my y-intercept. Well, the only purpose of this line right here is to tell me what my slope is. So if it's parallel, I'm going to use the exact same slope. Perpendicular, I'm going to make the reciprocal and make that 1/2. Since this is positive, I'm going to make this negative. Now I'm going to use those slopes and this point to find the equation of those given lines. I'm going to go back to point-slope form and then plug in my values. So y1 is 1, m is 2, and x1 is 2. And then I need to clean this up. So y minus 1 equals, distribute out the 2, 2x minus 4, add 1 to both sides. So y equals 2x minus 3. So there's my equation of the line that's parallel to it. Now over here, we're going to start the same way. Point-slope form. I would encourage you to write this equation out to memorize it. And I'm going to use the same point, so y1 is still 1. M, however, is negative 1/2. So x minus x1, x is 2, from that given point. Now remember what we said about fractions. Take the denominator of the fraction and swing it over. I would keep the negative with the numerator just to make it easy. And now we clean it up. So we have 2y minus 2 equals negative x plus 2. Now we solve it for y, so I add 2 to both sides. So I have 2y equals negative x plus 4. Divide through by 2. So my final answer will be y equals negative 1/2 x plus 2. So this line is parallel. This line is the perpendicular line. This line is the parallel line. Okay? Hope that makes sense. Refer to this example as much as you need to and be prepared to be able to do this. Okay? Good luck, and we'll see you guys again.